Hello friends, my name is Dr. Sachin Borse. Presently I am Professor and Coordinator International Relations, Imperial College of Engineering and Research, Pune, India. Today we will discuss about the lift and drag. As we know that lift and drag are more important for aeronautical engineering, but as the mechanical engineering, drag is more important to us. Now we'll move and see what is the drag force. So drag force is the force which will be exerted by flowing fluid on a body in the direction of the flow. It is called as drag force. Drag force is denoted by F suffix D. What is the effect of this force? It will oppose the motion of the body in the fluid, and will try to move the body in the direction of the flow. Drag is of course undesirable phenomenon, and we always we cannot eliminate the drag force, but we can of course reduce the drag force, like flow over the car, flow over the aeroplane. This gives rise to the drag force. So drag force is expressed in the form of coefficient of the drag, which is the ratio of drag force divided by a half rho a u square, where u is free stream velocity and a is the area of the body projected in the direction of the flow. So this way we describe the drag coefficient. Now let us see what are the types of the drag forces. Basically there are three types of the drag forces: parasitic drag, then induced drag, and then wave drag. So we'll see the parasitic drag. This drag is produced whenever the object moves through the fluid. The parasitic drag is produced whenever the object moves through the fluid. So there are three subtypes of parasitic drag. First is the skin friction drag. We already know this. This is the drag caused by the friction of the fluid against the surface of the object moving through the fluid. We know that this skin friction drag is because of the shear stress which is produced in the fluid, and this friction is created. The shear force is maximum at the wall. If you compare a lecture on the boundary layer, you will see that a turbulent boundary layer gives more shear stress and thus more friction as compared to the laminar boundary layer. Now a question comes: how to reduce the friction drag? So one of the way is to delay the point at which the flow will become turbulent from the laminar. Other ways to reduce the skin friction drag or friction drag which is existing because of the shear stress is to make the surface more and more smooth. So the skin friction drag is proportional to the area of the surface, and it is proportional to the square of friction velocity. Now we'll move to the second parasitic drag, that is called as foam drag. Foam drag is also called as a pressure drag. This is because of the pressure force. The foam drag is created due to the shape and area of cross section of the solid body moving through the fluid. The streamline shape of the body will reduce the foam drag. An object with the larger cross section and blunt shape will have the larger foam drag. Now let us compare different shapes. Suppose the plate flow of the fluid over the plate. So what is the foam drag? Foam drag will be 0 in that case, and there will be 100% skin friction drag. Now take the case of the blade, uncambered blade. We will see that there will be foam drag about 10%, and 90% will be skin friction drag. Now take the case of the spear. So here almost foam drag will be 90%, and skin friction drag is about 10%. Now move to the vertical plate. Plate is perpendicular to the floor. Here there will be 100% foam drag and 0% skin friction drag. Now let us understand how this skin friction drag and the foam drag or pressure drag contribute. Now let us see that flow is coming with the friction velocity u infinity and some elemental area dA is there. So there will be two forces acting on this elemental area. One will be shear stress, shear force, that is the tau W into the dA. Shear stress, tau W is the shear stress at the wall. So shear force is tau W dA, which is acting along the elemental area, and there will be pressure force PdA, which will act normal to this elemental area and towards the elemental area. Now let us suppose that this plate elemental area is inclined at angle theta. Now our interest is to find the drag force in the direction of the flow. So you have to resolve the shear force. So shear force we resolve, it will be tau W dA cos theta, and if we resolve pressure force which is perpendicular, it will be P dA sin theta. So now based on this we can say what will happen if the theta becomes 0 when theta becomes 90 degree. In between this both the friction drag and pressure drag will exist. Now we see, let us see now. Suppose the plate is horizontal to the flow direction, then what will happen? If you see the shear force, tau W dA cos 0, cos 0 is 1, so there exists a shear force. And if you see the pressure force, P dA sin 0 will be 0, so there will no pressure force, but only the there will be friction force or friction drag. Now we will move to the second case. The plate is vertical. Here the theta is 90 degree. So skin friction drag will be 0 because tau W pressure force, but only the there will be friction force or friction drag. Now we will move to the second case. The plate is vertical. Here the theta is 90 degree. So skin friction drag will be 0 because tau w dA cos 90 is 0. So there will be only the pressure drag. So friction drag is 0. Now we'll move to the next drag under the parasitic drag, that is the interference drag. This drag is because of interference of the different flow fields of the different components of the body. Let us see the aeroplane. The body of the aeroplane is called as fuselage, and this is the wing. So whenever the flow field of the fuselage and the wing interact, it will create the interference drag. Similarly, other example is the weapons carried by the fighter aeroplane and fuselage. The flow field between these two components will create the interference drag. Now we'll move to the second type, that is called as lift-induced drag. It is obvious, the name suggests that this drag is created because of creation of the lift force in the wing. So aerodynamic drag force which will occur whenever moving objects redirect the airflow coming at it. Now you take the case of the wing. In the wing, what happens? The pressure below the wing is higher than the pressure above the wing. Pressure above the wing is less. Pressure above the wing is less, and pressure below the wing is higher. Because of this pressure difference, there is a flow at the wing tip. You can see in the first diagram. Because of this, it induces one additional drag component. So this drag is created because of lift force. So this drag is called, you can see the diagram too, you can see the lift force, and because of this flow distortions, it is creating one additional drag. That additional drag is called as induced drag. So that drag is called as lift-induced drag. Now let us move to the third type of the drag, that is called as wave drag. It is the drag, obviously, which will retard the forward moment of aeroplane in the supersonic and transonic flow as occurrence of one phenomenon called as shock. What is shock? Shock is the abrupt change in the flow property when flow goes from supersonic to subsonic. So this shock formation can occur any place in the supersonic flow, and it adds to the drag. That drag is called as wave drag. Provision should be made to avoid this wave drag, to avoid the shock, by adopting thin and swept-back wings for the aeroplane. So this is about the wave drag. So our purpose in designing, whether it is aeroplane or to the car or any bus, basically car and aeroplane, is to reduce the drag. so that we need less fuel for propulsion of the vehicle. Now let us have comparison between the friction drag or pressure drag. Pressure drag is also called as the form drag. So let us see the difference. Friction drag, so this is because of the shear stress exerted by the fluid at the surface of the body. Please understand, the shear stress at the surface. So this is a drag or opposing force to the body because of the shear stress at the surface. Now pressure drag, it is because of pressure force exerted by the fluid at the surface of the body. Second difference we will see, friction drag, if the free stream velocity u infinity is parallel to plate, then only friction drag will exist. If you can see in the pressure drag, if the free stream velocity u infinity is parallel to plate, then what will happen? Pressure drag will be 0. Now we move to the next case. Friction drag, if the free stream velocity u infinity is perpendicular to plate, then friction drag will be 0. So there will be only pressure drag. So if you see in the pressure drag, if the free stream velocity is perpendicular to plate, then only the pressure drag will exist and friction drag will be 0. So the friction drag depends on the type of the surface, whereas pressure drag depends on the shape and size of the body. So this is the difference between the pressure drag and the friction drag. Now let us move to the streamline body. What is a streamline? It is an imaginary line in such a way that the flow will not cross this line. Whenever there is formation of wake or recirculation, it will not form the streamline. So in the CFD, whenever we plot the streamline, we see the place where there is gap between the object and the streamline. So what is our aim in that case is to adopt the shape of the body to the streamline. When we adopt the shape of the body to the streamline, that body is called as streamline body. In case of streamline body, flow separation is delayed and it is moved in case of the wing towards the trailing side, and there will be very small area of the wake or recirculation. So in case of streamline body, the pressure drag is very small, but there is considerable skin friction drag. So in overall the drag is less for the streamline body. So we should go for streamline body to reduce the overall drag of the body moving the fluid. Now we'll move to the blob body. Blob body is the body in which it do not coincide with the streamline. In the other words, we can say that this body has a separated flow over a large area of its surface, and because of this, the blob body has a large pressure drag as compared to the friction drag. So overall drag is large in case of the blob body. So in the large area, the wake is. and because of this the blob body has a large pressure drag as compared to the friction drag, so overall drag is large in case of the blob body. So in the large area the wake is formed, so here the overall drag is more. So let us move to the there are two components of the force when the body moves through the fluid. One is along the direction of the flow and another is perpendicular to direction of the flow. The force in the direction perpendicular to the flow is called as the lift force. So lift force is similar to the drag force. It is expressed in terms of lift coefficient CL. So CL is lift force FL divided by half rho A U infinity square, where A is projected area in the direction of the flow. Now as there are two forces existing, then we may be interested to find the resultant force, that is capital S. So resultant force is calculated as square root of FL square plus FR square. Thank you for listening to this. If you have any questions or comments, you can write to me. Thank you for listening.